In this recording, we'll discuss fat breakdown. So lipids, or fats, are used in a lot of different ways in our bodies. For example, they're used to make our cell membranes, so the phospholipids that we are familiar with. They are used to make steroid hormones. Excess fats can be stored in adipose tissue for energy supply. So there's lots of different functions of lipids in the body. But we have to transport them in a very particular way because of their basically hydrophobic nature. So remember, they don't really like water because they are hydrophobic compounds, but quite a bit of our body is made of water. So in order to transport fats, we use something called a lipoprotein. And I'm going to show you a picture. Where is it? This is a lipoprotein. Okay. So you've got proteins and phospholipids that form these little balls, basically. And the lipids that you are transporting are on the interior. Okay, so that's what a lipoprotein looks like. We have different kinds of lipoproteins. We've got two main kinds. We've got HDL and LDL. And you may have already heard of these. These are types of cholesterol transports. So you've got HDL cholesterol and you've got LDL cholesterol transports. So HDL are high density lipoproteins. These carry cholesterol to the liver so it can be broken down and the cholesterol will become part of your bile. Okay, and then that bile can then be used to do the emulsification of fats, right? Now these HDLs, these are highly desirable, or these are helpful lipoproteins. If you have your cholesterol numbers checked, your HDL should hopefully outnumber your LDLs, because your LDLs, these low density lipoproteins, these are the least desirables. These are lousy ones. These carry cholesterol to your peripheral tissues. Okay. They can be used to make cell membranes, so that's not really a bad thing. They can be used to make hormones, which is not really a bad thing, but they can be stored for later. And that's kind of where things can go downhill, because if we store too many, we're never going to use them later. These are the ones that can accumulate in your blood vessel walls. If that happens, you could develop atherosclerosis, which is basically your arteries are narrowing because you are creating these cholesterol plaques, and calcium can be part of these plaques as well. This impedes blood flow. Okay, so this increases peripheral resistance. This can increase your blood pressure. If one of these plaques ruptures, breaks off, travels, it could create a clot. So all kinds of bad stuff there. These LDLs are part of these plaques, along with fibrous tissue, platelets. Kind of everything just gets bundled together to make these plaques. If it gets bad enough, you could start to suffer from atherosclerosis as well, which basically means your arteries lose their elasticity because of these plaques. So you could, again, create a clot or a thrombus to completely block off a blood vessel. Could lead to a heart attack or a stroke, something bad like that. So that's those stinky LDLs. So again, just to remind you, this is what these lipoproteins look like. We've got these protein molecules when all these phospholipids, and you know phospholipids arrange themselves to where the polar heads would be exposed to the water, the hydrophobic nonpolar tails would be in the center, and then the lipids that we're transporting would be in the very middle of all this. Alright, so let's talk about how we do lipid catabolism. Okay, we can take the fats and the lipids from our diet and we can break them down into fatty acids and glycerols. Once we break them down into the fatty acids and glycerols, each of those components can be used in a different process. Okay, so the fatty acids can be converted into a molecule called acetyl coenzyme A, or acetyl coenzyme A, acetyl-CoA. Okay, or acetyl-CoA, however you want to pronounce this. That's fine. This process, this is called beta oxidation. Okay. Now, because we didn't go into a whole lot of detail about cellular respiration, this term might not stick out to you, but let me just tell you. The acetyl-CoA plays a big role in cellular respiration. Okay, and remember cellular respiration was one of the ways that we produced a lot of ATP. So this molecule can actually be really helpful to us. If, we'll go back. All right, if those fatty acids are incompletely metabolized, okay, and you have excessive acetyl-CoA, if you got a lot of acetyl-CoA, okay, being produced, the liver is going to be like, what do I do with all this stuff? It's going to turn it into ketone bodies. Okay, we call this ketosis. Okay, now ketoacidosis, because these ketones, they do have acidic properties to them. Ketoacidosis can actually change your blood pH. It can make it too acidic. Okay, this is a form of metabolic acidosis. Okay, so we've thrown around respiratory and metabolic acidoses and alkaloses. So this is one of the ways you can end up with a metabolic acidosis. You could be suffering from ketoacidosis. A lot of people that have type 2 diabetes that they do not control very well, or people that are starving themselves or having really extreme diets, these can lead to ketoacidosis. And again, anytime we change the pH of your blood, then that runs the risk of you doing some major damage to your body. So this can actually ultimately be fatal. Okay, so just make sure you're making wise decisions. Okay. All right, so that's the fatty acids. Okay, we can take that acetyl-CoA, we can do a little bit of cellular respiration, no big deal. If we have too much of it, we end up doing ketosis. That can mess with our blood pH, so hopefully we don't do that a whole lot. But the glycerol part, we can turn that into glucose. Okay, so glycerol, I mean, almost kind of looks like glucose already. This occurs during gluconeogenesis, so remember we're making new glucose. Okay. Unfortunately, the fatty acids themselves cannot do gluconeogenesis just because of the pathway. So let me go to this picture. All right, so glucose. All right, so here's the acetyl-CoA that we just mentioned. So you can do fatty acid oxidation or the beta oxidation. We can make acetyl-CoA, which can then go into the Krebs cycle. So the citric acid cycle, Krebs cycle, same thing. We can then go to the electron transport chain, also known as oxidative phosphorylation. This is how we get a bunch of ATP. So this acetyl-CoA, it can be nice for us, okay? But remember, if we make too much of it, we're likely to do ketosis instead, which could be bad, okay? Now, the glycerols, okay, can be used to make glucose, and we can just start from the very beginning and go through this whole path. But unfortunately, let's see, the pyruvate step, this step right here, okay, you can't go backwards, so we can't go from acetyl-CoA back this way to make glucose. That's just not really how it works, okay. But the glycerols, we just use those in a different way. All right. So far, everything that we've broken down, we can use it to our advantage.